Okay. Hi everyone. Today I'm going to tell you a bit about NoSCD development and how cargo-nono can hopefully avoid some of your troubles. Who here has like a rough idea what NoSCD stands for? Well, it's good, half about. Yeah. For those who don't, I'm going to go a bit into what is this NoSCD thing and why should I care. Because, I mean, for some of you, it's probably not that close, but let's see. Yeah, let's start with the basics. Like this hash bang bracket structure is generally crate write attribute. You put it top of your entry file, like main.rs, lib.rs, and then it applies some attributes to your whole crate. And what it is essentially just Rust with no SCD, no standard library. And what is in the standard library actually? Like a lot of the nice stuff. The collections, I/O, FS, something you usually always want to have in your environment. So why would I not want to use, why would I not want to use SCD? Because sometimes your target platform doesn't let you. And a lot of those times, it's in restricted environments, usually embedded with microcontrollers, etc. They're because as in the standard library, you usually have also the assumption that you can allocate stuff. You have some operating system running. In NoSCD environments, you sometimes don't. And one of those other platforms is to some degree WASM. I know that's not quite true, but I also don't want to go too deep into it because I think it might confuse you with the later talk. And some other more exotic targets. For example, when I was first really touching on NoSCD stuff, I was working on pwasm. For those of you who know Parity, they're working on an Ethereum client, and they have a WASM-based runtime or like language for Ethereum smart contracts, but let's not touch the blockchain today. And also highly portable code in general. Like, even if you don't care that much about embedded, you don't especially care about WASM, it's generally maybe a good idea, if you're a library author especially, to still try to be NoSCD compatible. But yeah, then just don't use the SCD if you don't want to. Like if you work for embedded, why don't you just not use it? We'll see it with an example. Let's just create a new crate, new binary crate, add NoSCD top of the main.rs, add a dependency, and then try to build it for like a NoSCD target. This should be like a microcontroller Cortex M4 or something like that. And then it will explode. I'll give you like a non-pretty error, crate STD not found, if you don't even have an idea what an STD is or not. It will probably confuse you, and it also has like the bad property that it's very bad to locate where it comes from. It can basically, it will appear like the error location will be a very strange place you probably not find, or like you will find it and it doesn't help you much, which is not that fun. And that's where we come to the first problem. It's basically there is STD infection happening. Like every once you have one dependency that pulls in your the standard library, you're not in a good place. And the big problem is every dependency will do so by default, because at top of every crate you have like the auto prelude. That's why you can always in your code have a statement with use std, fs, etc. Because hidden on top, the Rust compiler basically inserts like extern crate std and a few other things. And yeah, it's generally a nice convenience feature, and you can also turn it off with the no prelude attribute, but it doesn't help you much. And even if you, in a crate where you're using all those dependencies, put NoSD on top, you will still get it. You have no way of preventing it really. So every dependency has to have this NoSTD crate attribute, which is not great, because then you essentially have to screen all your dependencies for one crate that might be missing it. And that's exactly the reason why I built cargo-nono, because I got that cryptic error message, and then I had to look through like 20 dependencies, sometimes they're sub-dependencies, and in the end I didn't even find it, which we come to later because there's like another tricky thing currently about it. Also it's not great because because every crate has to have it, it puts like a lot of burden on maintainers, and it also can fracture like the ecosystem. Some people, especially for older crates that don't have NoSTD support, because back then embedded wasn't that big, WASM wasn't that big, people are starting to fork the crates and also have to like republish the crate under a different name, so you can actually publish that on crates.io and all that stuff. And one extreme example is like, it's a really small crate, it hasn't that much of a usage, but I actually found some problems related to it. Or like, I found it causing some trouble for some people. And it's like it's an incredibly simple crate. It's like 4 lines of code. Some people should argue crates that small shouldn't exist, but it's a different topic. And there is one fork, which adds 2 lines of adding the NoSTD attribute, because that is required right now. And yeah, so you don't want to screen all your dependencies, and that's where cargo-nono comes to rescue. You just run cargo-nono check, and then here right now we only have the one dependency sorted, and then it especially tells you why STD is included and what you can maybe do to prevent that. And for example, one easy way, a lot of crates luckily at least introduce optional optional support. Like if you want to toggle it correctly for your dependencies, you often can turn the default features of your dependencies off, in this case certain, and then create your own feature. And then you can also pass the exact same options. You will pass to cargo build, to cargo-nono check, here the -- no default features, which will also toggle the correct feature flags. And behind the scenes, like how I'm implementing that, it's really fits here to the Rust and Tal because it's really hacky. It basically is code parsing and then resolving feature toggles. With the sim crate, which is a great crate if you want to do anything related to what your Rust code actually, like the structure of your Rust code and stuff like that. It basically tries to detect at the entry point, which is luckily always confined to one file, and that's comparatively easy to find out which file it is. It tries to detect if there is like syntax equivalent to just a simple like always on NoSTD attribute, or like a very simple conditional. Like this one basically is a conditional feature toggle where it is, if you don't have the feature STD active, it turns on the NoSTD support, which is sometimes done to, in STD environments, get better performance and keep the code simpler otherwise. Yeah, and then we know what the feature is called. It doesn't have to be specifically STD. It can be named a few different things. There are like 3 common names, I think, in the wild, but doesn't matter much. And then I basically had to implement the complete feature resolution algorithm that Cargo does. Not the whole dependency resolution algorithm, luckily. It takes in like all the dependencies that are in the crate, and then new dependencies, and then with the feature toggles you pass to it, tries to replicate which features are on and which are not. And it also has to replicate what I would call buggy behavior, but it has propagated right now already a bit, and I'm not sure if it's easy to remove without being a breaking change, which is this features of dependencies enabled if they're enabled in build dependencies. Which means if in your build dependencies, which the most common cause I've seen is Sterde, because you maybe want to read in a template file with JSON, and then your Sterde dependency has std activated. And then you also have it active in the non-build dependencies, the normal dependencies. And then you get a little problems. There are some ways to work around that. For example, setting a specific version to 42 Sterdes, then it loads it in 2 times, one for the build, one for the normal one. But that's not great. And that was also the reason why initially I screened all my dependencies and didn't find it, because I didn't think my build dependencies would toggle on my feature dependent, like my normal. The build dependencies features wouldn't be toggled on for the normal ones. Yeah. And one pain point about it also was cargo, sadly. Yeah, because there are, I mean, generally cargo is great. I love it as a build tool. But it is a pretty huge monolithic code base. Monolithic is maybe a bit mean because it's pretty modular. It's split up on like the subcommands pretty well. But if you want to use it as a library, it's not that nice. It's like you can't just say I want the stuff related to like fetching crates or for example resolving the feature toggles. And so if you include it, it's like a huge dependency. There are some ways around that. There is cargo metadata, which is a cargo subcommand, and there's an associated crate, which makes it very easy to consume. And then, you build your own stuff around on top of it again. I've heard that there are some ambitions for the cargo team to change that, to make it more usable for subcommands. But I also don't know of concrete efforts right now. And yeah, so we come to the second problem, which is my library is building, which is not that much of a problem in of itself. But here it's a bit annoying, because when you're building library crates, contrary to the binary crate we did earlier, you don't get any feedback at all. It will just silently pass. You think, oh yeah, it's working on the NoSD conditions, but it isn't. Which I think, I don't know completely reason, but I think it is because when it builds a library crate, it basically doesn't build an executable, and only the executables are specifically like built for one target, except for like target toggles and stuff like that. But I think that's the rough gist of it. Someone can jump in if they know better. That's also where cargo-nono tries to help again. This is like, when it's not visible, it's like this is like console output. It will tell you did not find NoSD attribute, and then tell you, hey, maybe you want to include it on top, maybe you want to do the optional feature NoSD toggle or not. And it will also try to help you in another way. If you especially have like a specific user std statement, it will tell you at which location, and then also if it works, suggest this replacement, because a lot of the stuff in the std, or like what looks that belongs to the std, isn't actually in the std. It's actually in the core library, which is a bit different. I mean, it's also in the automatic prelude, and but not all parts are. But a lot of the like operations, marker traits, stuff related to slices is still there, and that's also stuff you still want to use on normal on NoSD environments. And that's also one point where it's like really easy to switch your libraries to have NoSD support. Everything you have to do is essentially just switch out STD for core, and then it works. Yeah. behind the scenes of this is, again, code parsing and Rust documentation, interestingly, because I needed to find some way to check if something that's in std is also in core. And the easiest way to do that, what I found was to rely on the fact that every Rust installation comes with documentation by default if you install it with Rust up. In other cases, you probably will get some problems. And we use that. We basically in the background run a Rust up with rustdoc, which gives you the path of the Rust documentation. And there we look, hey, we first basically search, hey, where is the documentation for the this std item we included? And like we go 2 directories up, or like as many directories deep as we went, and check, go 1 directory over to core, go down there. If something is there at the same location, there is a very good chance that it still works. It doesn't always work, because sometimes same items exist for, items exist for std and core, but they're a bit different. Like for example, some constants or numbers I think are missing in core that are in std or stuff like that. And generally there is the caveat of cargo-nono overall. It's like very heuristic depends. As you've seen, there's like a lot of code parsing. If stuff isn't exactly as it is, it will break down. For example, here, if you have like a complex feature toggle for your no-std features, which I've seen a few times in OI, it doesn't work. And but in general, with like most crates I check out, these times like do small fixes. For it generally was either like it did a good job of scanning or evaluating if it supported no-std or not. And in generally, it's also built in a way that there are no false negatives, I think. Like it will tell you, it might throw wrong errors your way, but it generally doesn't tell you, hey, this crate supports no-std if the crate doesn't. And what's in the future? There is on the one side, one thing I'm currently trying to add to no-std, to cargo-nono, which is still a bit work in progress, and I hoped to get it out before this talk, but sadly didn't. There is a way which currently relies on nightly features like LLVM tools to actually scan and build artifacts for std symbols, which would work for both binaries and libraries, and doesn't rely on relies on less heuristics, and looks to be pretty spot on in checking your stuff. But yeah, it also relies on nightly, so it will, and I think it will for quite some time, so it will always just be a secondary mode for cargo-nono. And there is one bigger thing, which I'm not involved in, which is std aware cargo, which is the big thing, which if that comes through, luckily, you probably won't need cargo-nono anymore. That takes care of the fact that cargo currently isn't even aware of std as a thing, essentially. Like in the background, std and core are like normal libraries, mostly, but only the Rust compiler knows about them, automatically includes them, and they never touch cargo. So cargo also can't tell a program, hey, compile without no-std from the outside. And this RFC, which is also from one of the people from Ferro Systems, interestingly, tries to fix that. But it will also take some time for this proper solution to arrive. std aware cargo, like luckily now there's an RFC, still pretty new, have to go to the review process, etc. And that's why that's one of the thoughts I want to give you in a way. Like proper solutions can take a long time to arrive, and there is no shame in using something hacky if it helps you in the meantime. I also think no shame in advertising it. Like I often, I do it here today, and also randomly on the Rust subreddit. Like a lot of times, stuff related to OSD comes up, and I just plug it and tell people, hey, maybe try scanning it with that, or like do it for them. And a lot of people were very happy about it, or at least they told me so. And also there's another like very similar project which I built, which is cargo-nono, which checks for dead links in your documentation. Like if you're linking from one item to another item. For a long time there hasn't been something in Rust doc that lets you do that. And now slowly, I think it's still behind the nightly feature gate. There is a feature which basically makes it quite obsolete. But I was happy that I had it in the meantime. And yeah, that's about it. Contributors and co-maintainers are always welcome. There are a lot of features, smaller features and also improvements on the way. And also if you use it and find some ways to improve it, I'm very happy to hear your thoughts. And you can also find me on GitHub or Twitter as @HoboFan. And I'm also available as a freelancer from time to time, if you think that's interesting for you. Any questions?
Just one single thing. Do you have any ideas or plan about alloc?
Oh, there is an issue for it. I personally haven't had to use much for like the separate things, and there it also fits less. Like there are a few much more different approaches in the wild on how people handle like alloc and do I turn alloc on or off, and sometimes it's bundled with NoSTD. So I mean, I would like to have it in there too, yeah, and also, yeah. I mean, there are rough plans, but it's also not a priority of mine personally. If anyone wants to submit a PR.
Quick question. Is this something like basically to remove the dependency on something like a glibc or something? Is there an equivalent in Rust?
So sorry, I didn't catch.
The whole purpose of the NoSTD standard library.
I mean, of the feature, like of the attribute.
No, not the attribute. So basically, you have to use NoSTD because I'm guessing it has to do something like.
I mean, it has to do with the automatic prelude, like because by default you will get the STD for your crate provided to you by Rust, and you have to use that attribute to turn it off. Or no prelude.
No, slightly different. Basically, is this something like you have, for example, in C, you have the glibc, right? Basically the C standard library.
Mm-hmm.
And sometimes you link to a different C library, or you don't want to link to the C library at all.
Oh, you mean do you want to turn it off because you want to bring something different in?
Is that the reason why we have the STD is there? Because
I mean, then sometimes you don't, for libraries at least, you don't need it at all. Like you just do something that's on generic core operations, maybe. Then you don't need it, and I think, but they are not advanced enough for in my like embedded stuff. But I think most embedded systems like provide their own version or like their own standard library for their platform.
If I understand the question correctly, I think like Rust also uses libc on a lot of targets.
Oh, okay.
But if you want to use a different libc, like Muzzle or Muzzle or however you pronounce it, it's a different target than.
Yeah, yeah. For most, usually that's I think the third triple. Yeah. Also, like you have those build targets, and with those triples, and I think usually the third triple refers to what standard library flavor you get.
Okay. Yeah. So this basically makes sure that you don't have to depend on the
So the Rust standard library and libc are two separate things. Like libc is really just talking like with your operating system, whereas the standard library gives you, it's more like the C++ standard library, like heap allocated collections, fancy stuff like that. So it's better to think about C++ standard library than the C standard library.
You mentioned one thing, if a crate doesn't depend on the standard library, there might still be a performance reason to not specify no STD.
If a crate, I just say what I wanted to say at the first. Some crates have like optional STD support, and usually they provide like a stripped down variant. I think for the regex crate that applies, there is a no STD mode for it, where it's slightly slower as if you have STD turned on. Because then it can do some fancier stuff that works only if you have allocate. It can pre-allocate some stuff and something like that.
If you have no, okay, so if you have no STD dependencies, there's no difference.
If you have,
it's simply whether you have the ability to use standard library like structs and methods and stuff like that or not. So if you're not using them and you don't declare no STD, there's basically no difference except that crates that want to use you that can't use the standard library can't use you. It's simply because of the flag. Like that doesn't change, the flag doesn't change the symbols at all. It just says you're not going to use standard library and ensures that you don't use standard library. Basically.
Yeah.
So if you use CI, can you like build your own examples with no STD and check the build there?
Currently, do you mean specifically with cargo-nono?
No,
Or like,
let's imagine I make another vector for some reason, and it has
Yeah.
no STD, and then you said if I just build it, then it will compile even though it doesn't work if I actually use it in a no STD environment. So what's the way to...
I think one of the main problems is that with no you can't run tests in no STD, if I'm correct.
Yeah, I'm fine with running the tests in no STD as long as it actually runs or builds in no STD. Right? I can test with STD, but the library product still has to compile with no STD. So I'm asking, can I ensure that with an example file?
I think that I mean I'm not sure if you know more maybe, but as far as I'm aware, like the test harness, which also builds the examples, pulls in STD, and with there you essentially then also have I think the same problem with feature toggle, like the build dependencies spilling over the feature toggles of those. So, like from what I haven't tried that myself, but from what I've heard, it's pretty hard to test no STD compatibility with examples or tests.